Okay, so let's take a look at hydrogen. Since on my screen here it shows hydrogen a little bit taller. So the top number, this number right here, is what we call the atomic number. So the atomic number does two things for us in the periodic table. It organizes the elements, and so they go in order. The atomic number for hydrogen is 1, and then the atomic number for helium, which is in the other corner, is 2. And then when you go down to the next period, which is a row on the periodic table, the next period, lithium, the next one is 3, and then beryllium's 4, and it just keeps going. So the atomic number organizes the periodic table that way. So the periodic table is set up by atomic number. The other thing the atomic number tells us is how many protons the element has. And so protons are one of the particles that makes an atom. They're found in the center of the nucleus. And so if our atomic number of hydrogen is 1, that means we also have 1 proton for hydrogen. So that's atomic number. The next thing, the symbol, that is this part. The symbol is what we recognize we recognize the elements for shorthand. Scientists really like to be able to write things faster. They don't want to have to write out hydrogen every time they're writing down some chemical formula or some compound. And so instead of writing out hydrogen every time, they use the symbol H. So those symbols are basically just the shorthand version or the nickname of the elements, those symbols. We recognize those elements by those symbols. And that's what I was saying on the Brielle one. All the cards she was showing her had the different symbols on them, and that's what she was using to recognize them. Still impressive, but like when she went K potassium, that's because the symbol for potassium is K, right? And then, of course, you have right here the name of the element. And so that tells you just what the name is. And then there's usually a number on the bottom of the box. The number on the bottom of the box tells you the atomic mass. So atomic mass is a little bit of a different thing. It tells us how much each atom weighs. And those atoms' weight comes from the protons and neutrons that it has inside of it. So protons and neutrons are both found in the middle. They're both particles that make up the atom. And all of the weight comes from protons and neutrons. A proton and a neutron weigh 1. Or 1 proton weighs 1 and 1 neutron weighs 1. A lot of the numbers on your periodic table are not even numbers. They're not whole numbers. They have decimals. And that's because each element can actually have different numbers of neutrons. So some hydrogens can have 1 neutron, and some hydrogens don't have any neutrons. And so because elements can have slightly different numbers of neutrons, then they average them, and they put that average down at the bottom. If you see that hydrogens is like 1.001, that's because almost every hydrogen does not have a neutron. And so mostly they're all just 1 proton, which would just weigh 1. Whereas if you look at lithium below it, what's the number for lithium? 6 point what? 6.941. Okay, so that one's really close to 7. And so most lithiums have 3 protons. We know 3 because that's its atomic number. And so then most of them have about 4 atomic weight left over. So that would equal 4 neutrons. So most lithiums have 3 protons, 4 neutrons, to equal a weight of 7. but some of them only have 3 neutrons, and so they take that and average it out, and you get 6.94. For our class, what we're going to do is we're just going to always round whatever number that atomic mass says. So remember, 5 and up, you round it to the next highest whole number. Below 5, you round it to the next lowest whole number. So if lithium said 6.3, then you would round it down to 6. Okay? So all of what we're talking about right now, we're going to practice. And we're going to practice saying what's the atomic number of elements, how many electrons do they have, how many protons do they have, how many neutrons, what's their atomic mass, what's their symbol, what's their name. We're going to do a couple together first, and then I'll have you do a few on your own. Number of electrons. The way that you find number of electrons is the number of electrons always equals the number of protons. So you find out protons from its atomic number. You find out electrons by the number of protons. It's always the same. Okay? So let's take our first element, beryllium. And beryllium is number 4 on the periodic table. Sorry, I forgot to mention. Let's go ahead and take out our science notebooks, open to a new page, and title it Understanding a Box. Okay, so everyone sees on their periodic table, beryllium, it's Be there, number 4. And so if we look at beryllium, the top number on your periodic table is kind of off to the left, but it's the top number. The top number is the atomic number. So on your setup right now should look exactly like this in your notebook. And atomic number for beryllium is going to be 4. Yes, Zoe? Oh, thank you. 12 in beryllium. All right, so we know that beryllium's atomic number is 4 because that is the number on the top of the box. The next easiest thing is to remember that the atomic number is equal to how many protons that element has. So the number of protons is 4. Number of protons is always equal to the atomic number. And because the number of electrons is also always equal to the number of protons, that means the number of electrons is also always equal to the atomic number. And so beryllium has 4 electrons. So its atomic number is 4, its number of protons is 4, and its number of electrons are 4. Okay, next, the atomic mass is that bottom number. And so beryllium has an atomic mass that says of 9.012. We're going to round it, like I said, to the whole number. And so 0 is closest to the low, like it's under 5, so we'll go to the next lowest one of 9. So beryllium has an atomic mass of 9. The symbol is always right there in the middle. So the symbol for beryllium is Be. And the name right here, we just write beryllium for the name. All right, so all we have left is neutrons. This neutrons tends to be the one that people forget the most on how to do. Neutrons is the atomic mass minus the atomic number. So we have atomic mass of 9 minus the atomic number of 4. Yes, and so the number of neutrons is 5. On the test, it will ask you to do something like that. That's the thing that people forget the most, is how to find the number of neutrons. Okay? All right. Let's do another example. Let's go ahead and do neon. Okay, let's see who can find neon first on the periodic table and tell me what atomic number it is. Abby? Yeah, it's 10. So the atomic number of neon is 10. That's the number that's above it on the periodic table. Okay, how about what's the number of electrons? Anyone can help me with that? Yeah, Liz? It is 10, and we know it's 10 because... Why do we know it's not 10 electrons? Yeah, so the number of electrons will always be the atomic number. Very good. And number of protons? Who can help me with number of protons on neon? Zoe? It is also 10, because that will also always match the atomic number. Okay, let's do atomic mass. Who can help me with the atomic mass of neon? Remembering we want to round it. Calissa? Is how much? 4. On neon? So neon's atomic number 10 is on the right side there. 20, yeah. I heard 20, right? So the atomic mass of neon is going to be 20, because the number on the bottom there says 20.180. 0.1 is closest to 20, so we're going to round down to 20. Okay? And then what's our symbol for neon? Go ahead, Braylon. Ne, yeah. Ne. One important thing to notice on these symbols is the first letter for the symbol is always capitalized. If it has a second symbol or a second letter, it is always lowercase. It's very important to do it that way. The first letter is always uppercase, and if it has a second letter, it is always lowercase. The reason that is because if we have a chemical formula like table salt, then we can tell how many different elements are there, because every time we see a capital letter, we know that it's a new element. So there's a capital letter, okay, that's an element. There's a lowercase, so that's part of the element. Okay, that symbol is Na. We know that that is sodium. Oh, there's a capital letter. That means it's a new element. Oh, there's a lowercase. Okay, so we know there's only 2 elements here. If it was like this instead, then people would think that that's 4 different elements because there's 4 different capital letters. Every time you see a capital letter, you know that it's a new element. You have a question, Addie? Or you're waiting for this? Okay. All right. Let's do number of neutrons. Okay, Addie. Good. So we have 10 neutrons because we have an atomic mass of 20 minus an atomic number of 10. And 20 minus 10 is 10, just like Addie said. It will not always be the same number. A lot of the time it will be, but it will not always be the same number. And then the name, of course, we know is neon. Okay, I have 6 more that I want you to do. Do we feel confident that we could do the 6 on our own, or do I need to do another one together? Okay, let's do one more together, okay? And then I'll let you guys do it on your own. Thank you, Braxton, because I'm sure if you're confused, there are probably some other people that are also confused. Okay, so let's do, the next one is going to be carbon. So basically, on this box, you just have to remember they give you 4 key pieces of information on your box. You just have to remember what each information is. Okay, the top number is always a what? Yeah. What is the top number? What does that represent? When I was about to ask what the atomic number is, what were you going to tell me? On carbon? Let's see. Did we find carbon already? Carbon is 6. Yeah, very good. And so you knew it was 6 because the top number is always the atomic number. Yeah, good, Braxton. Top number is always the atomic number, okay? So atomic number for carbon is 6. The top number on any periodic table is always the atomic number. So you just have to remember that atomic number is the number on top, okay? All right, now, what things does the atomic number tell us? It tells us 2 pieces of information. Jackson, do you know one of the pieces of information it tells us? So it's one of these things. Good. So the atomic number always tells us both the electrons and the protons. It tells us that those 2 pieces of information. How many electrons do we have? How many protons do we have? And so for carbon, we know we have 6 and 6. So the top number is the atomic number every time, and that tells us how many electrons and how many protons. All right, the next thing that they usually give you is usually those 2, either 1 or 2 letters. Look, that 1 or 2 letters, what does that tell us? What is the 1 or 2 letters? What does that represent? Yes? The symbol. Okay, so we know that the 1 or 2 letters is always going to be the symbol. And so in this case, there's 1 letter, and that's C for carbon. All right, and then the next thing it tells us is the actual name. Okay, so we have carbon is the name, carbon. So top number is the atomic number, tells us protons and electrons. Then it has the symbol, the 1 or 2 letters that represent that element. Then it has the name of the element. Okay, and then finally, what's the last number on these? At the bottom of these boxes, what does that represent? You said what it is. Yeah, the number is 12. And what does that represent for us? Yeah, the atomic mass. Very good. Okay. And this one is 12.011. And so we would round down to 12. Okay. So the bottom number is always the atomic mass. That tells us how much the one of that atom weighs. So 1 carbon atom weighs 12. Okay. The units that we use for that, you don't have to memorize, but it's AMUs. And that's atomic mass units. And so it weighs 12 atomic mass units. Like I said, you don't have to memorize that one, though. All right, so then the last thing that we need to know, then, is the number of neutrons. And how do we find the number of neutrons? Yes? Yeah, we do the atomic mass minus the atomic number, which in this case is what minus what? Yeah, 12 minus 6. Atomic mass goes on top. So 12 minus 6, we get 6. So 6 neutrons. Okay. That was